Today we were working on 9.4, which is perimeter and area in the coordinate plane. By the end of this, I just want you to be able to use distance formula, slope, equations of lines, things like that to be able to actually find the area of a shape. Some of the shapes are going to be nice, easy rectangles. Some of the shapes are going to be a little bit more difficult. We're going to do one here that's pretty easy, one here that might take a little bit more work, and then the last one here, which involves the equations of some lines. That way you have an idea of what you're expected to be able to do. All of this involves stuff that you've done before, so I don't think it's a huge thing that's that new. But anyways, here we'll get started with it. So graph paper, if you have it, would be excellent. If you don't, that's okay. Just try and make it as neat as possible, only because I think it'll help you out. So I'm going to graph my 4 points here. I have A at -4, 1. I always label the points just because if you're going to end up doing slope and distance, it helps to see them on the graph. So I've got 2, 4, which is up here. I've got 4, 0, which is way over here. And I've got -2, -3, which is down here. And that's point D. This thing looks like a rectangle. I'm pretty sure it's a rectangle. Let's take a look. My lines are really not that good. It looks sort of like a rectangle. We should probably check and see if the opposite sides are at least parallel, or maybe it's a parallelogram, I don't know. So in order to see what kind of shape this is, even, I know my lines are a little bit off. So like if you think that I just missed that it was a rectangle because my lines weren't that good, you can actually connect it and make it look really nice. So if I do that, you can't quite tell what it is. So I'm going to double check my points, -4, 1, 2, 4, 4, 0, and -2, -3. This one might be a parallelogram. Now I'm starting to think it's not a rectangle. So anyways, if I do the slope to try and check and see what this figure is, so I'm going to check. I want to check and see what shape it is. So if I find the slope of AD, it looks like I go down 1, 2, 3, 4, and then over 2. So that slope is -2. If I check the slope of, what is that? D, oh, 2, 4. See, I didn't even label it. This is point B. For BC, that slope goes down 1, 2, 3, 4, and goes over 2. That slope is -2, and that was of BC. Those sides are parallel. Let's check the other sides. If I do the slope of AB, it goes up 2, 3, and then goes over 1, 2, 3, 4, 5, 6. So if it's up 3 and over 6, that slope is 1/2. If I check the slope of DC, that goes up 1, 2, 3, and then goes over 1, 2, 3, 4, 5, 6. All right, so this is at least a parallelogram. So a parallelogram, the slopes are parallel on opposite sides, and as far as the area goes, you need base times height. So in a parallelogram, that can come a couple different ways. Your height and your base could look, a little bit different depending on which way you look at the shape. And I guess we can do whatever one makes the most sense. So I am going to need to find the perimeter, so I might as well find the distance of the sides. That could help us out as well. So I'm going to use the distance formula. Actually, you know what? I'm not going to use the distance formula. I'm just going to make these little triangles around the sides. This looks like this might be an easier way to find this one, because as I'm looking at this, trying to find the base and the height looks like it's going to be a little bit difficult. So if I make a little triangle here on the outside, it looks like that this height is going to be 3 and this distance is going to be 6. If I use the Pythagorean theorem to find this distance of AB, I should be able to do that because that's 3 squared plus 6 squared equals C squared. 3 squared and 6 squared is 45, so that means C is equal to the square root of 45. So there's that, which if you reduce that, is equal to the square root of 9 times the square root of 5, which is 3 square roots of 5. So that distance AB is 3 square roots of 5. Now, since we know that this is a parallelogram, we know that the opposite side should be congruent. That means DC is equal to 3 square roots of 5. Opposite sides in a parallelogram are congruent. That's why I'm doing that. So I've got two of the sides. I should be able to go find one of the other sides as well. Let's make this just a different shape. Not a different shape, but a different color. This distance is 2. This distance is 4. So if I do that, that would be, wait, what side am I doing? That's AD equals 2 squared plus 4 squared is C squared. So if I do that, 2 times 2 is 4, and then 16, that means C is equal to the square root of 20. If you reduce that, that reduces to 4 times 5, which is 2 square roots of 5, which also means that BC is equal to 2 square roots of 5. Again, because the opposite sides are congruent in a parallelogram. Perimeter, you should be able to add those up. So 2 square roots of 5 plus 2 square roots of 5 plus 3 square roots of 5 plus 3 square roots of 5 equals 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 square roots of 5 units. So that's your perimeter. If you're having a hard time following that, just roll it back, try and watch that again. But all of this is just your basic Algebra 1 stuff. So from there, I need to be able to find the area, like I said. There's a couple different ways you can go about this. We know that base times height is the area of a parallelogram. If we were going to do that, we would need to be able to know, let's label it, I'll show you. So if I was going to do the height, I need to know the height across this way and be able to find that. Now that might not be the same angle as the one on the side. So the height could be a little bit different than what AD is. I know that we understand what AD is. But when you do the height, it needs to come out to a right angle. So if I do it again and show you with a line, let's just use this one. So the height would have to be a nice right angle that goes across. I'm trying to make this as close to a right angle as possible so that you can tell. Now, if I took this and I put it over here, you can see that it's not the same as the side. The height is actually different. The side is not at a right angle, so that's not going to be what the height is. So you could find the distance across this shape. It would be a little bit difficult to do that, but I can show you a way that makes it, a little bit easier. So let's get rid of this. So we're going to be smart about this here. This whole shape, if I go all the way around, and let's use a different type of line. That way, well, I guess I can't. So if I make another triangle over here, and then I do another triangle over here, you can tell that there are 4 triangles on the outside of this. So it looks like that if I was able to find, and I'll scroll down a little bit so that you can see, for the area, I can find the area of the rectangle and subtract the 4 triangles. Now, I know that you're saying that you could find the area using the base times the height, and I'm just saying that this might be a little bit easier based on the orientation of this parallelogram. It looks like trying to find the base and the height of this particular shape would be a little bit difficult, so I think that this is going to be an easier way to do this question. If I do the area of this triangle here, I could do base times height divided by 2, which is 4 times 2, which is 8 divided by 2, which is 4. That area should be 4 of this triangle over here on the side. I should be able to do base times height divided by 2 to find the area of this triangle. 3 times 6 is 18, and 18 divided by 2 is 9. I should be able to do the same thing with this triangle over here. I also know that this one is 6, and this one is 3. So that area should also be 9. And you can see a pattern here. This one's going to be 4. Okay. So now I need the area of the rectangle. Well, this is just a rectangle. So the area of the rectangle is, what is that? So this total thing is 8 across because 2 and 6 make 8. And then 4 and 3 make 7. So it's 8 times 7, which is come on, which equals 56. Ooh, it's not writing here. 56 units squared. So I should be able to take the rectangle and subtract out the triangles. If I do that, the rectangle is 56 square units, and then I should be able to subtract the triangles, which together, those triangles are 9 plus 4 plus 9 plus 4, which means I'm doing 56, take away 9 and 4 is 13, and 13 is 26, which means total, that should be 30 units squared. So that means this area of this shape right here is 30 units squared. Cool. That was a lot. It's the algebra in this is not anything new, but the process in doing this on a shape and knowing what kind of shape it is involves a lot of math and stuff. Being able to just draw a rectangle around it and then subtract out those triangles is a method that will work pretty much every time, and I think it's a little bit easier than using the actual formulas sometimes. So we'll do it again with the next shape, and we'll see what comes up, and we'll see what kind of difficulty level it is. Again, if you need to roll that back and make that go a little bit slower, you can. How are we doing? So I'm going to find the area of this polygon as well. Again, if you pause this and try it out on your own, it's going to be way more meaningful for you. So I would try that first before you just watch me do it. That's going to, for you, it's going to make you be able to get the most out of this. So I would try that. So this is x, which is 4, 2. Y is 2, negative 3. And z is negative 4, 0. All right. Now, I don't know what kind of shape this is going to be, but it doesn't look like it's anything normal. I'm going to connect this with these lines. Neatness here is a big thing. It's going to be so much easier for you when you do these questions if you're neat about it. But this shape could be a kite. But I don't even know if it looks like a kite. I don't think it would be one. The sides look like they're all different. I think, again, the easiest thing here is going to be to split this into triangles. So this is a method that I think will work most of the time, and it's going to be something that makes it a little bit easier for you. If I just, again, drew a rectangle around this, and I made sure that the rectangle hit all 4 vertices, and it's going to work out, and it's going to be good. So, you know, make the rectangle hit all 4 vertices to make this work. So I should be able to do this in the same way that I did the last question. It looks actually nearly like the same shape. So this is 3, this is 1, 2, 3, 4, 5, 6. This is 2. This is 1, 2, 3, 4. Wait, 1, 2, 3, 4, 5. Okay, so this is slightly different. I've got, this is 2. This is 1, 2, 3. This is 1, 2, 3, 4, 5. I'm just counting, by the way. I'm not even using the distance formula. You can just count up what they would be. So if you add up all the different triangles, the area of this triangle is 20 divided by 2, which is 10. The area of this triangle right here is base times height divided by 2, which is 9. The area of this little triangle here should be 5, because base times height divided by 2 is 5. And then the area of this shape here should be 3 times 2, which is 6, divided by 3. Which means I can take the total rectangle, which a red rectangle, I'm talking the whole big outside thing, should be 7 times 8 again, which is 56. I should be able to subtract out the triangles. So those triangles together are 10 plus 3 plus 9 plus 5, which is 13. 13 and 9 is 22, and 22 and 5 is 27. So I should be able to do 56 minus 27. If you subtract those two, 56, 36 minus 7 is 29. So it's slightly smaller. So what we just found is that this right here is 29 square units. This one didn't ask us to find the perimeter, which is why we didn't use the distance formula. We just had to find the area. Again, that triangle method will work pretty much every time. It's something that's really helpful. If you have one where you just need to, it's a straight up trapezoid or something like that, I don't know. Say you had something that was like this and it was just, a trapezoid like this. You could just, do the same thing that we just did if you wanted to, or you could actually use the formula. So it can work out either way. You can totally use the formula or use the triangle method each time. It doesn't matter. So you can pick what's going to make the most sense for you. The math doesn't change. So moving on to the next slide, I've got one here. There is one like this on the practice packet that I have from class, so please don't skip over this one. This is something that is going to be helpful. This is the last example, so we should be good in right about 20 minutes, maybe a little bit more. So y equals -5 is this line here. If you don't know how to graph that, Google it. Your algebra is failing you. So this is y equals -5. X equals 2 is a vertical line that goes through 2, so you should have a line that looks like this. That line is x equals 2. Last one is y equals -2x plus 7. It's hidden a little bit here. Let me see if I can bring this to the front. Cool, sorry that was blocked a little bit. So -2x plus 7. My graph, I didn't leave enough space, did I? Well, I shouldn't really be moving that. So I'll put in 7 way up here. It's okay. My bad. So that means +7 is the y-intercept. A little review for those of you who don't know algebra. Y-intercept is this. This is your slope. So I count down from there. My slope is -2, which means I'm going to be going here. I don't know why I put a point there. I went down 2 and over 1. I go down 2 and over 1. I'm intersecting this line right here at this point at 2, 1, 2, 3. So that point is 2, 3. So I've got that coming down here. Now, it looks like that I haven't left enough room on my graph to do this, so I'm going to need to move this over because it's not going to intersect y equals -5 until way later. So I'm going to take these lines and move them over. If that just ruined your whole graph, I apologize, but you need to be able to make this thing work out. So hopefully you were just doing it on graph paper. So if I move over everything that I just did, here, I'll just redo this. Okay, so we'll get rid of those. So basically what just happened is I took that, I just moved everything over, just so I have more room on my graph. So I started again up at my y-intercept of 7, and then we went down 2 and over 1 to here, and then we went down 2 and over 1 to here. So they intersect at 2, -3. So one of the vertices of this triangle, so vertex, I'm going to call it vertex A, is going to be at 2, -3. So I'm going to call this A. Vertex B, obviously, you can see is down here already. It's down at 2, -5. Our last vertex, this is why I moved the graph. I could tell that it was going to keep going down. So down 2 over 1 would be here. Down 2 over 1 would be here. This is why it's helpful to count on your graph, because if you don't, your line starts to look a little bit off like mine did. So this should go down this way. There's a shadow, so I can't see my hand right now. So it goes down like that. So it looks like my graph was a little bit off. So I hope you followed that process. If you didn't, you can always roll it back or ask someone next to you in class who understands what's going on. So here, if the point should be 6, -5. So that vertex C is 6, -5. If you can't tell where these lines would have intersected, you could have used the system. So if you can't tell where the lines intersect, use a system. For example, say you needed to know where does y equals -2x plus 7, oops, I wrote a 5. And what other line did we have? Negative 2x plus 7 and x equals 2, for example. Where do they intersect? You could just substitute them into the equation for that. In order to solve this, you could just say, oh, well, I'll take y equals negative 2, and I would substitute the 2 in for the x, and solve this. You end up with y equals negative 4 plus 7, which is 3. So that point, 2, 3, ends up being that vertex that we found anyway, which is way up here at vertex A. So if you have a hard time graphing and you know that you're not going to do this neatly and you're not going to see what your intersection points are going to be, solve it with a system instead. That's going to be something that is a little bit easier for you. So, but really, if you graph it neatly and you can see where they intersect and they're whole numbers, then go for it. I'm going to try and give you numbers that work out kind of nice. So anyways, we need to be able to find the area and the perimeter of this triangle. So I can count up and see that my height is 1, 2, 3, 4, 5, 6, 7, 8. I can see that this distance is 4. So, and then my area would be base times height divided by 2, which is 8 times 4 is 32 divided by 2, which is 16 square units. Last thing I need to do is the perimeter. I need the hypotenuse. So I should be able to do 8 squared plus 4 squared equals c squared, c being that side right there, which means that that's 64 plus 16 equals c squared, which is the square root of 80. So square root of 80 reduces to, well, is there anything, 16 times 5, I think? That's going to reduce to 4 square roots of 5. Yes, you have to reduce the square root. No, you can't round it. I'm sorry if that sounds mean. So your perimeter should be 8 plus 4 plus 4 square roots of 5, which is 12 plus 4 square roots of 5 units. So you end up with that. Not too shabby. So yeah, you leave it like that. I guess you could round it, you know, if it was a real world application, but as far as the math goes, that's totally fine to leave it like that. So I've got my area up here, nice and labeled. I've got my perimeter right here, area, perimeter. So that's that. Hope you enjoyed. Email me with questions or ask someone around.